There we go. Audio's good. And let's get started, guys. First of all, I wanted to talk a little bit today about something that we did, like I think maybe on the Monday of the last week, which was this idea here, the antiderivative. And this is the formula, of course, for an antiderivative, given that you have a derivative that looks like some sort of function. And I thought I'd pick an example because over the break, people who were catching up on homework were sending me questions. And I wasn't on my computer every day, but I did my best to kind of get back to people as I could. And this kind of question popped up a couple of times. So I thought this would be a good thing to start with. I'll review antiderivatives and review sort of this idea at the same time. The idea here is that people are looking at questions like this and they're going, what do I do with divided by 5? They're having a hard time, like they're saying, do I have to use quotient law? And I'm going to try to convince you that you actually don't have to look at this as a divide. First thing I'm going to do is get the keyboard in my way. Go away. There we go. First thing I'm going to do is, if I need the antiderivative of this, I'm going to actually treat this like it is a derivative. So I'm just going to say, well, this is the derivative of some function that I'm going to call f of x. Okay? So now I'm going to use my antiderivative formula, but before I do, I'm going to change it into a multiply. So this saves me from having to think about it like it's some sort of division and then I have to break out my quotient rule. So does the logic of that make sense to you? Think about it just in terms of arithmetic. Dividing a number by 2 is the same as multiplying it by a half. Because that's how division works, right? Division is multiplied by a reciprocal. So now I can just treat this 1/5 and this 1/3 like it's the a in my formula. So now I can just go to my formula. If this is f prime of x, then f of x is the a value, and here it is again, right, the a, which is 1/5, divided by n plus 1, n is 4, so 4 plus 1, times the x to the power of n plus 1. So that took care of the first term, minus the second term, which is 1/3 all over n plus 1. That's a terrible plus sign. Times x to the 3 plus 1. And there we go. Now all I got to do is simplify that, and I've got my answer. So that's f of x is 1/5 divided by 5 times x to the 5 minus 1/3 over 4 times x to the 4. And think again, remember that when you're dividing, 1/5 divided by 5 is the same as saying 1/5 times a 5th. So this is 1/25 times x to the 5 and 1/12 times x to the 4. And the final answer that's in the answer key is probably going to go back to the way it was kind of given to me and multiply this together to make x to the 5 over 25. So I think I had some people who were doing this homework and they were getting a little lost in the fractions. So hopefully that clears it up a little. And they were seeing this not just in antiderivatives. There's lots of questions like this in all parts of the Chapter C booklet, where you have to deal with a coefficient that is fractional, which, again, you can write 1/2 of x like this, or you can write it like that. But when I'm looking at doing calculus, it's usually easier to think about it that way. Okay, so any questions about that? Did that make sense? Let's do one more of this kind of antiderivative. Now this one, I kind of have the problem again of this 1/2 here that looks like it's 1 divided by 2, but I'm thinking of it as a half times my variable. But the fact that the variable, let me go to a different color here, the variable is in the denominator has to be treated differently than the coefficient having a denominator. So if that makes sense to you, let's see if we can change this. So the first thing I'm going to do is I'm going to change this to g of x is equal to 4x to the 1/2. And this is now going to be 1/2 times x to the -3. So there's my first step for this, is I have to, again, let's see, make that better. I have to treat this like it has to be an exponential rational exponential form rather than radical form. And I have to treat, again, this 1/2 coefficient as a coefficient rather than as a divide. So now it's actually, again, really easy to go back, and if you need to look back at the formula, again, I'll give you this formula when we quiz it, or actually when we quiz this stuff, I'm thinking we're gonna quiz this stuff on Friday, just as a little quiz, and you can use your book. It can be open book if you like, so you get access to this formula here. Okay, so it's a over n plus 1. So again, I'm going to say that this is actually my derivative. So that means that my original that got me that derivative, that's what antiderivative is to take a over n plus 1 times x to the n plus 1 plus a over, that's going to be n plus 1 times x to the n plus 1. So that's just me using the formula. Any questions on how I got any of those terms or coefficients or exponents? So that means the g of x was, so that's going to be 4 over 1/2 plus 1. Okay, I'll skip a couple steps here. 1/2 plus 1 is 3/2. So 4 divided by 3/2 is like saying 4 times 2/3, which is 8/3. And then 1/2 plus 1 is 3/2. This fraction here is going to end up negative, so I might as well just make it a minus instead of a plus. And 1/2 divided by -2 is -1/4 times x to the -2. And now how they leave the answer is interesting. They probably don't go back to a radical because this thing is not going to be just a plain radical. It's got this extra power of 3 on top. So I'm just going to leave it as a fractional exponent. I honestly don't remember if that's what the answer key does or not. Somebody could look at that for me. So I'm actually going to leave this one alone. I think this term, that's probably the way the answer key is going to work. This one, however, I'm going to change it back to the way it looked before and get rid of the negative exponent. We usually don't think of negative exponents as being the simplest form of an answer. Now I'm going to kind of take a guess. I didn't actually look. That's the way that the answer key gives the answer. Somebody could let me know if I'm right about that. If they changed it around at all, what they might have done is they might have taken x to the 3/2 and made that the square root of x cubed, which, by the way, you can also think of as the square root of x squared times x, which is x root x. There is, the argument can be made that if you have to go to radical form for your final answer, that this is simpler than that. So if anybody, if I was wrong about the way they wanted the final answer, they could have said g of x is equal to 8x root x over 3 minus 1 over 4x squared. So these two answers are identical, and again, I honestly don't remember which way the book does it. Somebody could check that out and let me know. Oh, sorry, you know what? I kind of forgot something. Oh, and I forgot it on the last one. Oh man, I just had like a flashback to when I was in calculus. I'll tell you my calculus story. I don't think I've ever told you my calculus story. So unlike you guys who actually are in a school, a very big high school that has an AP program where you can take, what would you say? You can take the AP course, and if you get a high enough mark, you can challenge for the credit. at university, so you don't actually have to take the first semester of university calculus. My high school had an introductory calculus course, but we weren't a big enough school to be AP accredited or whatever. So I just took the intro calculus course, and I did really well in it. And then what happened is I ended up in first year calculus, and I was one of those guys that finished high school kind of early. I was actually only 16 when I started university. So I was in university my first year, and I'm realizing as I look through the syllabus and stuff, it's like, this is exactly, my intro calc course was a full year, not a half credit like yours. And I'm realizing I've done all of this stuff, and I'm fairly good at it. And then I kind of hear from other people from other high schools that, hey, they don't have to take this course because they already got the credit from their high school. So I went and talked to the prof, and I said, is there any way I could, challenge the exam and not actually have to take the course? And the guy says, oh yeah, we do that all the time. And he says, show up at my office at this hour. So I show up at his office, and I sit down and I do the exam. And he, of course, profs don't do a lot of their own marking. He got one of his graduate students to do it for him. And the graduate student, phones me and says, oh, come by the office. And at first I think, oh no, I thought I did really well. I'm getting phoned into the office here. Maybe I bombed it. And the guy said, well, you actually only made one mistake, and here's the mistake you made. The mistake is, guess what I forgot? Does anybody remember what I forgot here?
Mr. Kellogg.
Good morning.
Your screen is completely green.
Completely green? Green.
Yeah, we can't see a thing.
Wow. Okay. Let's see if I can fix that. I'm going to go back out of here. Let me know if anything that I'm doing here fixes this. Okay, what can you see now?
Green, but like with some markings.
Green with some markings. Can you still see me?
Kinda, but in green.
Kind of put in green.
Yeah, there's like 4 of you at the top.
There's
But
4.
have a green overlay over top of you.
Okay, yeah. The fact that there's multiple of me is normal, because that's the video capture right now is capturing me. But when I click on this, you don't see my OneNote page anymore?
No, it's like
I don't see anything. I just see green.
Wow.
You see like the taskbar? I only see the taskbar like repeated 4 times in green.
So the taskbar repeated 4 times in green. That is weird, because it's looking totally normal to me. Okay, I have an idea. I'm going to do something different. I am going to go to, okay, I'm going to pause the recording so that I don't have any of your names pop up when I open Teams. There we go. Go back to my OneNote. I said go back to my OneNote. There we go. Can you see me again? Okay, let me finish my story. The one in my challenge.
I don't see you, but I do see the OneNote.
I don't care if you can see me anymore. I'm going to get rid of that camera anyway. That might be the problem. That camera might be the thing that made the whole thing goof up. Anyway, finishing off my story, the one mistake I made. Does anybody know what the mistake I made is here? What did I forget? The constant. That was the 1/2 mark mistake I made on my challenge for the first year exam, is that when you take an antiderivative, remember, when you do a derivative of a constant, it becomes 0. So when I do an antiderivative, there might have been a constant here, but I didn't know about it. So my final answer has to always have plus a constant. So I forgot it in that one, and I forgot it in this one. And wow, talk about history repeating itself. That's the one mistake I made back when I challenged the exam. Then here's how that story ends too. The grad student called me in and said, oh, you made one mistake. You forgot this constant, which is pretty trivial, but we got to count it for a 1/2 mark, so you get like 99.5%. And he said, I got to tell you, this actually isn't last year's or last semester's exam. Our prof usually, this is actually way harder than the exam we give. Our prof usually gives it because when he gets people questioning whether they can challenge the course, he gives them this exam that's way too hard, hoping that they'll go away. So they were expecting me to fail it, and I didn't. So that was nice. I actually only made 1/2 mark of mistake. So they gave me the credit, and they gave me back my, what was it, maybe $400 or whatever a course cost in those days. I think they're now about $600 for a first-year course. Inflation. Anyway, so I need an answer of plus c. And like I said, I honestly don't know which way the book would give the answer. I would think they probably leave it, oops. Oh, okay, I gotta flip this over again. Okay, let me know if this gets goofy again when I flip it over. Everything still normal? Woo!
Yes.
Yay, good. Okay. So I honestly don't know which way the book would give the answer, but I suspect it's this one. All right. I can maybe go through one more antiderivative here. How about we'll do a word problem? I know some of you aren't physics students, but you all did enough physics in grade 10 science to understand problems like this. And this is an antiderivative problem. So we have a formula for the velocity of a person running. And it says in the problem that they're running, they slow down, and then they reverse their direction and come back. So step one is I'm going to have to, for A, get a position time equation. And remember that velocity as a function of time is the derivative of position as a function of time. So that means what I can do, oh, people are messaging me here. I'm going to just make sure that if people don't have microphones, I do have the chat open. Okay, all right. Good, good. So anyway, like I was saying, the position's derivative is velocity. So what I want to do is do the antiderivative of this formula. So position as a function of time is, and again, we do this the same way we did the last ones. We go a over n plus 1 times the variable to the exponent n plus 1. Remember that this is n of 1, right? And then minus, that kind of looks ugly. Let's see if I can fix that a bit. Plus 1. There we go. Minus a over n plus 1 times the variable to the exponent of 2 plus 1, or n plus 1. So position time is 6 divided by 2, which is 3, t squared, minus 3 divided by 3, which is 1, t cubed. Now, I have actually met, and I got to admit, when I was younger and I was doing this stuff a lot more frequently, people who don't really need this step. They're so good at doing antiderivatives that they can just look at this thing and come up with that thing. And if that's you, that's fine. I actually would not mind if that was what you did. Okay, I don't really need to see this step, but I think for most people, you probably should show me the formula that you're using and show me the work. Okay? All right, next. Okay, what am I doing with this? Oh yeah, how far do we move in 1 second? So I want s of 1 second. So that's going to be 3 times 1 second squared minus 1 second cubed, which is 3 minus 1, which is 2, and s positions in meters here because velocity is in meters per second. So there's my A answer. For my B answer, it says how far does she move in the first 2 seconds, which doesn't take any more calculus. I just have to find s of 2 now. So that's going to be 3 times 2 squared minus 2 cubed, which is 3 times 4 minus 8, which is 12 minus 8, which is 4 meters. Then I had a couple people message me about this question over the break. How do I figure this out? She's back where she started when t is 3. That's nice. How far did she travel to get there? Now, when they say how far did she travel, remember that her displacement is actually 0. But that's not what they're asking me. They're asking me how much was the distance there and back to however far away she went. So what I need to know is I need to know at what point did she turn around? And guess what that point is? That's the point when velocity is 0. So I take my velocity equation, which was again 6t squared minus 3t, and I set that to 0. And then I have to figure out at what time did she turn around. So that's going to be 0 equals, and then 3t, and then that'll be 2t minus 1, right? You solve this by factoring. And so that means that either 3t is equal to 0, which means t is 0, which kind of makes sense, right? Like time is 0, so yeah, she stopped at time 0. But that's a trivial answer. The other answer is the one that I want. T minus 1, or sorry, 2t minus 1 is 0. So t is equal to, let's see.
Not be 2 minus t?
Oh, whoops, I just realized, thank you very much. I just goofed that up. Can I have a mulligan on that? Mulligan, 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 mulligan. Okay. 3t, 2t minus t. That's better. Oh, sorry, 2. Still goofed it up. There we go. 2 minus t. That's better. Thank you. So let me just go back and redo that first step. The first step's still the same. 3t is equal to 0, so t is equal to 0, which is, again, a trivial answer. Or 2 minus t is equal to 0, which means that negative t is equal to negative 2, so t is equal to 2. And that's actually really handy because I already know how far we went away at time 2. So from 0 seconds to 2 seconds, we went 4 meters, and that's where we stopped and turned around. Therefore, the whole trip was 8 meters. And that's how you get the answer. Now, there's one thing I kind of skipped over in this question. I didn't forget this time. I just decided to kind of ignore it. But remember that when you do an antiderivative, there could be a constant. But in this case, what do I have to assume about that constant? I have to assume constant 0. Now, what am I saying by saying that the constant's 0? Well, what I'm saying is that's the same thing as saying that we start, and I just misspelled the word start, at position s equals 0. In other words, the starting point of the problem has a distance of 0. And that's a reasonable assumption. So now, do you have to show that you made that assumption? No, I don't think I'd know that you made that assumption if you didn't actually include it as C. Okay, so that's how you actually do a problem like number 8. I might give you a problem like that on the quiz and then maybe a couple. You know what? The 3 problems we kind of did here would be pretty similar to what I'm going to quiz you on. I'm only going to give you 2 or 3 questions maybe. And we'll do that Friday. I'm not going to make it worth very much because this is a really minor part of the curriculum. In fact, if you don't get to this in our course, it's not a big deal because those of you moving on to AB calculus, you'll do tons of this stuff. In fact, this is kind of the introduction. The word antiderivative is pretty similar to what you call the process of integration and solving integrals. So that is a big part of the next calculus course. So this was almost an optional little topic, but I thought it was a good thing to throw in, and it's coming in real handy right now because I think we can make just a little quiz just based on this, not make it worth much for marks, and do it kind of as a test to see if the tech is working. Hopefully everybody knows how to find their OneNote. OneNote is something that if you're logged into whatever your device is in Pembina Trails and you open your Microsoft OneNote, it should take you directly to our OneNote. Here, let me show you a little more of what it should look like. I'll show you what it looks like actually for me. I'll stop the video because what I'm about to do is going to pop people's names up. So give me a second here to stop my video feed.